Okay guys, so when we are dealing with systems of equations, we're talking about two different equations that are together on one graph, and we are looking for the solution. The solution to a system of equations is the point where the two lines intersect. So in this case, where we have the line y equals negative 3x minus 7, and the other line y equals 2/3 x plus 4, we're looking for the solution to that, and if we're looking at the graph, we just need to see where do these two lines cross each other. So we can see that right here, the two lines are intersecting each other. And we want to be able to label what that point is. So I can see, I always know that we're dealing with the point in the terms x, y. So I need to figure out what is the x value of this coordinate and what is the y value of this coordinate. So I know that the x value, I'm going to start from the center and I'm going to go to the left, meaning it's negative 1, 2, 3. So negative 3, and I went up by 1, 2. So my coordinate here is negative 3, 2. That is my solution. That is my solution. Now I want to be able to verify that by plugging in the values of x and y that I got, negative 3 for my x and 2 for my y, into each of these equations. So remember that I got the solution of negative 3, 2, where negative 3 is my x and 2 is my y. And I want to verify that that is the solution to both of my equations here by plugging negative 3 in where x goes and 2 in where y goes. So that's going to be y equals, I'm going to start with the first one, y equals negative 3x minus 7. So my y is 2. So I'm going to replace y with 2. And then I still have negative 3x, but my x is negative 3. And then I still have minus 7. So I have 2 equals negative 3 times negative 3. That is a positive 9 minus 7. And I have 2 equals 9 minus 7 is just 2. That is true. 2 does equal 2, so then I know that works for this equation. I need to verify it on both equations within my system though. So now I'm going to write the second equation, where it's y equals 2/3 x plus 4, where my y, which is 2, so I'm going to replace y with 2, is equal to 2/3 x, but my x is negative 3 plus 4. So I have 2, bring that straight down, 2/3 times negative 3, well negative 3, I can think of that as being 3 over 1, negative 3 over 1. So my 3's actually just cancel here, and I'm just left with 2, but that negative still there, so it's negative 2 over 1, but I don't need to put over 1 because it's still just negative 2 plus 4. So then I'm left with 2 is equal to, with negative 2 plus 4, I have different signs, so I'm going to subtract, and I'm going to get 2. Keep the sign of the larger number so it's positive, and I have 2 is equal to 2, which is true. And so I know that because both of these ended up with a statement that is true, 2 equals 2, then I know that my solution that I plugged in works. Let me give you an example of a solution that does not work. So let's say I thought that my solution was right here, and that point is -4, 1. See, that works on the red line, but it does not work on the blue line. This point is not on this blue line. So if I tried to plug this point in, this point where it's -4, 1, -4, 1, if I tried to plug that point in, my answer here would not come out correct. So I would have -4 is my x and 1 is my y, and if I try to plug that into this blue line, y equals -3x minus 7, then I would, let's see what happens. So I have y, which is 1, equals -3 times x, which was -4, minus 7. That's 1 is equal to -3 times -4. That is 12 minus 7. And that ends up giving us 1 equals 12 minus 7 is 5. That is not true. That is not true. So that's how I know this is not the solution. For it to be the solution, both equations have to be able to get a true statement by plugging in that solution. So let's do another example. I'm looking at this line here. The blue line is -x plus 4, and the red line is just y equals 3. See how it's a flat line? It's a straight horizontal line. So y equals 3, that just, I can always look at that. I know that that is going through the y value of 3, and it's just a flat line at 3. And I've got y equals -x plus 4. So I'm looking at this. I've got my intersection, so my solution right there. That coordinate is 1, 3. This point is, I went over by 1 and up by 3, so that is my solution. So now I need to test that. I need to verify that that is true. So I'm going to do what I did with the other one. I have the first line of y equals -x plus 4, and my coordinate, I said my solution, the coordinate is 1, 3, so I'm going to plug in 1, 3 and for x and y. So the 3 goes in for my y, because that is the y value, and negative x, so -1, plus 4. So that is 3 is equal to -1 plus 4, different sign, so I'm going to subtract, so 3 equals 3. That works, because 3 equals 3 is a true statement. That is a true statement. So I need to verify it on the other equation. Y equals 3. So the other equation, y equals 3. My x is 1, but I don't have an x here, so I don't need to plug that in anywhere. And my y is 3, so 3 equals 3. Well, there's not much to do there. We see that that's true. So let's move on. I'm going to do another example where I actually remind you how to graph a line. I know we've done a million of these, so you might not even need to see this, but let's do it anyway. So the first line here is y equals -5 over 2x plus 6. So I'm going to start at my y-intercept of 6, and from that point I need to move based on what this slope is telling me. So it's going to go down by 5, 1, 2, 3, 4, 5, and then over to the right by 2, 1, 2. I'm going to do a third point just to make a straighter line. So down 5 from this second point. I'm going to go down 1, 2, 3, 4, 5, and over 1, 2. So now I can draw my line. I've got my line there. And then I have the second equation, y is equal to 2x minus 3. So I'm starting at my y-intercept of negative 3, because it's minus 3 here, so negative 3, and my slope is 2. Remember, when I have a slope that is an integer, I need to put it over 1 so that I have a rise over run. So rise of 2, run of 1. Rise 1, 2, run 1. Rise 1, 2, run 1. I'm going to do another 1, 1, 2, run 1, just to get a straighter line. And there's that line. And now I can look at this and see that I have the solution right here. That is my solution. And that coordinate is 2, because I went out 1, 2, and 1 is my y value. So my solution is 2, 1, and I need to verify that the same way I was verifying it on the other ones. So my equation y equals negative 5 over 2x plus 6. I need to verify the point 2, 1, 2, 1, where 2 is my x and 1 is my y. So I'm going to replace y with 1, because that is my y value. 1 equals negative 5 over 2 x, which is 2, plus 6. Now my 2's cancel each other out. So I have 1 equals this. The negative 5 remains there. Negative 5 plus 6. And then that is 1 equals, it's different signs, so you subtract, keep the sign of the larger number so it's positive. 1 does in fact equal 1. So then we know that we've got the right answer, we've got the right solution here. Let's do it with the second equation of y equals 2x minus 3. Y equals 2x minus 3, where y is 1, equals 2 times x, which is 2. So 2 times 2 minus 3, that's 1 equals 2 times 2 is 4, minus 3, that's 1 equals 4 minus 3 is 1. That is true. We know we've got the right one. I'm going to do one more, and hopefully this is enough to help you guys understand what we're doing with these systems of equations. So I've got this one. Sorry, I made a little mistake when writing this one, but it's y equals 3x minus 5. So I'm going to start at my negative 5 intercept, minus 5 right here, and a slope of 3, so that's rise 1, 2, 3, run 1. Rise 1, 2, 3, run 1. Rise 1, 2, 3, run 1. So I'm going to draw my line through there. Trying to make it as straight as possible. So that's good enough. And then my red line will be y equals x minus 3, so I've got a y-intercept of 3, and if I do not have a number in front of my x, that means it's 1, right? And it's 1 over 1. 1 over 1. If it's a whole number, it's 1 over 1. So rise 1, run 1. Rise 1, run 1. Rise 1, run 1. So I'm just going to draw. It's not a great line, but you get the idea. So my line goes through there like this. So my solution on this one is right here. And that coordinate is 1 for my x value, and the y value is -2. 1, -2. So now I can plug that in to my, I'm going to plug those values in. I have y equals 3x, oops, sorry, off the camera, y equals 3x minus 5, and y equals x minus 3. And the coordinate that I found as my solution is 1, -2, where that is x, that is y. So I'm going to plug those values in for my x and y's. So I have y, which is -2, equals 3 times x, which was 1, minus 5. So -2 equals 3 times 1 is just 3, minus 5. That's -2 equals 3 minus 5 is -2. That is in fact true. -2 does equal -2, so I know that that is a good solution for the first one. Let's verify it on the second one. So I have y, which is -2, is equal to x, which is 1, minus 3. Well, -2, 1, minus 3 is in fact -2, so then we end up with seeing that they work for all the solutions. Hope that helps, and make sure you guys get your exit ticket done, because that is very important. That's how I'm going to judge where you need to be on Friday. Make good choices and have a good day.